Today I'm going to be talking about identifying and using complex numbers. And I actually have a video for you guys to see first, just kind of give you an intro of this. Now from this video we learned that I is the square root of -1 and I squared is -1. And we're going to be using the value of I to solve for to simplify radicals that before we couldn't simplify. Okay, so if we have something like this, it says find the square root of the number. Well, this is the square root of -64. Before, we would say this isn't a solution, we can't have anything. But now we know that the square root of -1 is I. So we can rewrite this as the square root of -1 times the square root of 64. And now we know the square root of -1 is I, and the square root of 64 is 8. And we write it always with the I at the end. So our answer is 8I. Let's do the same thing for the square root of -24. Let's break this up as -1 times square root of 24. That becomes I, and the simplified of square root of 24 is 2 square roots of 6. And the way we write this is 2I square roots of 6. And the very last one, we're going to break up again. -3 times the square root of -1 times the square root of 49. So we now have -3 times I times 7. We can multiply the -3 and 7 together to be -21 times I. So we can now simplify square roots that have a negative in the radicand. All right, let's move on. It says find the values of x and y that satisfy the equation. So if we look at this, these two equations are equal, and we can actually set the x, the 3x and the 27 equal to each other because they're in the same place. And we can set the 6i and the yi equal to each other. So we can solve for the x and the y. Well, if we divide by 3, we get 9. And if we divide by I, we get 6. So we can do the same thing for the other one. We do -12x and 60. So we get x equals -5. And then yi equals a -13i. Divide by I, because you can do that. Y will equal a -13. Now I'm going to show you how to add and subtract the value of I. We can manipulate I just like a variable. It has the same properties. So this first one, since we don't have anything in front of the parentheses, those can go away. And then we can combine like terms. Negative 3 plus 8 is 5, and 2I plus 7I is 9I. Okay, and ask you to write the answer in standard form. Well, that's A plus BI. That means the constant goes first and the imaginary number goes second. So that is in standard form, and we can leave it. This next one, we do have a negative, so we have to distribute that. So we have 16 minus 9I minus 2 plus 9I. Well, the 9i's cancel, so we get 16 minus 2, so we get 14. All right, next up, we can multiply as well. So we can distribute. That gives us 14I minus 2I squared. Now, if we remember at the very beginning, I said that I squared is equal to a negative 1. So we can replace I squared with a negative 1. So we can rewrite this as 14I minus 2 times negative 1. And we always want to do that to make this simplified, to simplify it the most. So now we do 14I minus plus 2, because negative 2 times negative 1 is positive 2. But this is not in standard form, so we have to make sure to make this 2 plus 14I. And now we've got our final answer in standard form. This next one we can FOIL. 7 and 8 is 56, plus 40I minus 42I minus 30I squared. So we can say 56 minus 2I, and we can change this to a positive 30. Since I squared is a negative 1, and then negative 1 times a negative 30 becomes a positive 30, we can combine the 56 and the 30, and we are going to get 86 minus 2I. All right, let's FOIL again. This is going to be 81 plus 45I minus 45I minus 25I squared. The 45i's cancel out, so we get 81 plus 25, because that turns into a positive, and we get 106. And that is our final answer, because our i's canceled out. All right, now our very last one is about circuits. Imaginary numbers are used a lot in electrical engineering, okay? And one of these is finding the impedance of this series circuit. So in how we find that, we have a formula which is I is equal to R plus Li plus a negative Ci. Well, what do those stand for, though? Okay, what do they stand for? Well, our first one, we have to match up those shapes. That is our resistor, which is our R. We have kind of the loopy one, which is going to be our inductor. Which is going to be our Li. And then our very last one, which is the two lines, like that, is going to be our capacitor, which is our negative Ci. Okay, and if you look at the symbol at the very end, we see the little omega symbol at the end of each number. That is our unit. Our omega symbol is ohms, which we measure this in. Okay, so what we're going to do is we are going to plug all of this information into our equation. So if we look at the very top one, that's our resistor. The right one is going to be our capacitor. And our very left one is our inductor. So we're going to plug this in. So our impedance is going to equal 4 plus 6I plus a negative 9I. And then we're going to combine like terms, and then we get 4 minus 3I ohms. And that's going to be our answer. So let's try this one down here. Okay, so this top one is going to be our resistor. Our right one is going to be our inductor. And the bottom one is going to be our capacitor. So we're going to plug this in, and I get I equals 14 plus 7I plus negative 8I. And our answer is going to be 14 minus I ohms.